Welcome everyone, citizens of the internet, Linux, PS3, Voodoo, fans and everyone. Starting with, of course, I was busy with different things, also coding and whatnot. And anyway, first of all, where would even be, what did I wanted? Ah, yeah, right. So first of all, a couple of things, quoting Louis Rossmann. Don't be a half bitch, be a full bitch. And apparently not only Google YouTube live streaming, but also additionally the 3DFX Voodoo took this seriously. Can't make this nonsense up. You've seen me struggling, the recurring fans and people in the audience. My YouTube live dashboard before I flew to Moscow, Russia last week, I was struggling with this YouTube live dashboard beta thing. It stopped working. Out of nowhere, it was working before and didn't really update Firefox, Chrome, and it stopped working before we switched here to IPv6 dual stack. And in Russia, surprisingly, it worked. Also, it wasn't working on Windows Edge for some reason. So in Russia, it magically worked with the same SSD here, with the same ThinkPad. And to my surprise there, so you see nothing of my setup or something, just like the YouTube dashboard stuff also is a whole bitch, or more likely, not really sure. What is really strange, in Russia I also later live streamed over a VPN to the data center here of us and somewhere else in Germany, and to avoid some intentionally or unintentional throttling there. So I do the same now. So I have no idea why in Germany, Berlin, our office, maybe I need to go to Starbucks, but any tips wanted. So the YouTube live stream stuff, again, I would think I come back to Berlin and it's amazing, but somehow not. And the same, of course, here on Firefox. And yeah, no idea why I already switched to a VPN, our own data center. Doesn't make a difference, really strange. Also here, recurring theme, also security vulnerabilities and stuff that is broken. So even I have, well, looked there, did the VPN, no idea. This is, why all the stuff is broken. So what is up next? Of course, soon PS3, because all the fans of that fun are waiting, obviously, but also some lessons learned. What do I do next? Also next, of course, PS3, yes, I know, but I cannot always travel with that. But yes, we will continue just even probably this week because PS3. But we will also do two other things. One thing is here the OCO 01 transmitter efficient with Silicon Motion. For this hardware isolated 3D chip only does not even exist to Windows XP, so this shipped with Windows XP from OCO back in the day. This nice little marvel, I hope. Anyway, if you are interested in this, 1 GHz transmitter efficient, Guinness World Record, smallest PC back in the day. We will also do this. So there only was from the vendor, again, the vendor of this Silicon Motion of the 3D, so Blinks 3D, also used in a couple of ThinkPads and maybe even one laptop per child or something. That's what, maybe, not really sure, but at least some ThinkPad. And so there never existed a 3D driver, not only for Windows XP with what this shipped, but never for open source Linux. This is really sad, and I have a backup of some partial documentation, so I will try to get this working. Also, maybe more interested for many of you here, the Sony Vario P, this video, unsurprisingly, surprisingly running very well. Intel Pulsebo PowerVR GMA 500 graphics, certainly, well, not the most interested, but certainly more interested than Voodoo and PS3 for many of you. And so this is up next, and yes, PS3 and SJ Octane, just so many things, also trying to build an audience and want to learn and educate stuff. And one major note here for education, of course, PC emulator for everyone wanting to try this at home. You don't need to buy any fancy outdated hardware stuff. You can just take PC emulator, amazing software, totally approve of that. And I continued because certainly I want to not leave this started low-level bare metal graphics unfinished. What is missing here for our new code here for this is texturing, and boy is that a whole bitch. They really took this seriously at 3DFX. I said this before, like never meet your heroes because I'm a little bit disappointed. And what am I disappointed? So I spent a couple of more hours trying to get this to work, the texturing here on the Voodoo. And I made some progress. Some things were my own fault. My own fault was, here's the texture loading. The Voodoo doesn't support 24 or 32-bit true color images. It internally always differs to 16-bit color anyway. And so I have here from the Verge, by the way, fun fact, although it is a deaccelerator, at least it supports it. And so I need to convert here the data, the Lena test texture here that I used for the S3 Verge. So what I'm doing here, we have here RGB 24-bit, uncompressed 3x8-bit, like 24-bit true color. And the Voodoo doesn't support this, so we on the fly convert this to a RGB 1-bit alpha, like transparent or not, and otherwise 5-bit for red, green, and blue. So we convert this here, we load RGB, shift this 3 bits from 8-bit to 5-bit, shift this to the right, and then we shift this together. Again, we do this because we need to remove the first bit. This is why we first shift this. We could also end this, but just shift this and then shift this back in place here. For blue, of course, 0, and then 5 and 10 bits for red and green, red, and the alpha channel 15 bits. And one fault why this was not working, I had the black image. Initially, I forgot the alpha channel, right? So you see 1 bit, and why everything takes like forever also for the PS3. Obviously, all this, each bit needs to be right. If you mess up 1 bit on all the way, then yeah. So this was my fault. I also had here a couple of more bits, like in the texture stuff, until like 1 bit was off by 1. Also, what is really tricky, but there is one major thing, so stay tuned 1 more minute. So one thing, let's maybe quickly grab here for blend. One thing is really tricky is here the color path, because this is so much more complex for all the special effects that you can get with specular highlights and ground shading for other lighting effect or multi-texturing. Many of the things the S3 Verge can as well, but the Voodoo has a couple of more, well, the major things the Voodoo and the S3 Verge accelerate or implement in hardware, all those stuff, but the Voodoo is certainly a little bit more tricks there, left and right. And texture mode, let's see here, where is it? Probably somewhere like here. Come on. And what is really tricky on the Voodoo is to get the data path correct, because even with this bit set, it still was black, and it's still, so I spent a couple of hours training my brain in graphic driver programming for the PS3 RSX certainly, and where here it comes somewhere like this, yeah, here. So this is really tricky. So it took me quite a while, and of course it looks like easy on the first glance, but when you try to implement this and somehow one thing doesn't work and the other thing doesn't work. And what is a huge help for this, if I would just been back in the day with the Verge, I couldn't get this to work with my neighbor. All of this was new protected mode on DOS with 32-bit linear addressing for reaching the memory mapped I/O region and this stuff. So back in the day, super complex when we were 16. But even today, if I would not have PC emulator, all this virtualization nowadays, of course, makes this so much easier to debug because you have the PC emulator code. And boy, super shout out to the Sarah Walker, I think is the name of the author of PC Emulator. Huge shout out, amazing achievement. I can't imagine how many months it took to get the Voodoo emulation right there, because boy, even after spending a couple of more hours, it's debugging through all this, and thanks to the author, the code is quite readable of PC Emulator. So what I'm basically doing is comparing the step by step why my texture is not appearing on the screen, and I fixed a couple of bits. So I had here a couple of those selections, because you have here like color 0 and color 1, so you have a local color and another color, so color local, color other, and you need to set all those bits of all the multiplexing here, because I also had to figure out what is in the intended way, because you can select the texture color here, you can also select the texture color here and here, And then you need to understand, and this is what makes this so much a longer process to understand, what did the developer of 3DFX really intend here to use, because then it's not only selected, it's also, you can select here whether to multiply it here, and then it's always added by 1. I also had to understand how is this intended, because I don't want to have any of this multiplication and blending. Why is this so? This is so because you can select here with the iterated color of the garage shading to have lightning effect. This is why you would need to set this. So you can have a plain texture, you can have 2 textures like a multi-texturing, and then you can have additionally iterated RGB for ground shaded lightning effects, and also add this and invert this for all kind of special combinations of textures and lightning, for all this kind of fancy effects, because after all this fancy effects of lightning, dynamic lighting and so on are coming down to just fancy stacking of textures and all this iterated like white or colored lightning highlighting effect. So I had to, like, initially I thought, yeah, you take the texture from here, but I think it's more intended to take the primary texture from this part, and then 1 hour is gone and another hour is gone, and you tinker around and play and try and error and debug this, and after all, and then also the coordinates, you can choose between fixed and floating point coordinates, and then you need to figure out how do they intend the scaling, because the texture coordinates U or V, or how Voodoo 3DFX is calling this, S and T coordinates there on the texture. Of course, they all need to be scaled properly to even show there's something. So after all this work, it still doesn't work. So you need to be patient. Also for the P3, again, why do I do this? First of all, I try to educate here, get more people in Mesa programming, also for myself, to really, of course, I knew all the concepts, but it's something else to know the concepts and to really implement this from scratch, because just reading others' code and fixing some off by 1 or some bit missing is something else than really getting this to work. And also highlighting how important documentation is, because like those whole bitches they are at NVIDIA without providing any documentation certainly ain't much fun if you need to reverse engineer everything. But now the highlight, and you will not believe, so now for all the people who tuned in, you tuned in the right moment. The whole bitch it's unbelievable. I could not believe what I found, because after debugging all this back and forth in a couple of hours, I found out my texture memory is 0, although I write a texture. So I had to get back to the drawing board and debug a texture loading, and thanks to the amazing code of PC emulator, let's go to the texture, which is actually the code like here. And normally you would think texture loading is super simple, right? You have your memory mapped memory there to your PCI address space, and what you normally would do, and what like on like virtually probably all other graphic cards from NVIDIA, ATI, everything that existed, even on the S3 Verge, like basically everything, 99%, you can just write or copy your texture like with a memcopy or something, basically anything, and write it to the linear frame buffer there for your texture memory. And you will not believe that doesn't work on the Voodoo. It's unbelievable. So I have here a loop. Of course, I read this from file, open a file, read the texture here, the bitmap converts this here, and write this here to the texture address space. And this doesn't work because the people from 3DFX there with the Voodoo card, texture, where would this texture stuff be? Somewhere. You can't just copy it. It's hilarious. I've never in my life ever seen such a creative invention, and this is why you really need to understand this, and why reverse engineering is so difficult. This is the biggest nonsense I've seen in my whole life, if I even find it back in the documentation. Here is texture format, must come here somewhere. So basically you need to copy it in a very special way. Texture access. So what I told you before in an earlier video, what I found already interesting is if you don't have any of those texture levels, again, this is mip maps, this is this pyramid stacked of texture detail levels of the highest detail, and then like stacked layers of smaller mip map texture layers. And what I found already interesting is that you always need to specify the texture address in VRAM and video memory always to the address of the highest level of detail, even if you're not using it. So this example, you have your texture, and this you don't use, and they call this virtual, I think somewhere they mentioned virtual address or something, virtual texture, virtual because it's not there. And I could have just used the highest level, but I just had from the S3 Verge example the slightly lower resolution already, and it's DOS in real mode, and yeah. So yeah, I could have set it so that this texture memory address space is exactly my address space, but whatever. So, but even this, so you always, even if this is not, so this is not the actual address in video memory. So this is, if you have a lower detailed, lower resolution texture, this will always be virtually something else. But that's not the problem. I already got this working. The crazier thing is you can't even copy this directly. So if this is your video memory, like texture memory address 0, so this is like, here's a video memory that you see on the screen with your texture, like for example the texture of this Firefox browser window. Normally, like on any other 99% of all the other video graphic cards, you would just copy this. And I did this because naively I was, well, how you doing, right? And turns out, reading the PC emulator code, because my texture memory was 0, right? I was copying this and it didn't end up there, it was 0. What the heck is going on there? And the PC emulator code to the rescue, turns out, and they document this here, just so here's the texture load format, turns out, and I overread, so I scroll over, so yeah, okay, fine, you know, obviously you have the 16-bit, yeah, whatever, scroll over, I just copy this, right? So yeah, lesson learned, never scroll about anything over the specification, it can always be important. So not only I was writing this because I have a 16-bit texture, so I was naturally writing this in 16-bit writes. I thought, yeah, certainly no problem, right? That wrong. That is the first wrong. So I think they document here somewhere even that all the writes have to be 32-bit, like double words in Intel speak, which is, yeah, okay, fine. Somewhere there should be documented, but whatever, you can believe me that it's written here somewhere. Generated address clamp something. Somewhere it is written for, yeah, your only 32-bit address are valid. And thankfully the PC emulator implemented this, because so my first issue was I was writing 16-bit and it didn't end up there. Then I was looking through the code, debugging through the code, and I saw, wait a second, why are they not handling this with 16-bit writes? They don't even have this in the switch statement in the code. And then I was like, is this a bug or what? And then I was reading, but wait a second, in 32-bits they have this specifically write 16 and write 32. And I said, why do they? And then I found this text like, wow, they even emulate this accurately in that they throw, so in PC emulators, emulating this, I don't know how the real hardware, I didn't have the real hardware with me in Moscow, but this is perfectly emulated in PC emulator, literally in throwing 16-bit writes away. Okay, so far so good. This is why I now load here 2 texture texels at a time, load here the first, shift this together, increment here this J variable for the texture load by 3 because RGB, and then do the same again. Yes, this is open coded. In prettier code we could have some macro and whatever. Just first I need to get this to work. So do this again and then write a 32-bit with my protected mode far address helper thing here. Okay, fine. Of course a little bit unhandy. Normally I would find this easier to just do, but so okay. But this also doesn't work, because then I thought, okay, debugged further and said, wait a second, why is this still not ending up at my texture memory address? Turns out that they have here some special format, and let's see, So what this Voodoo card is doing, and I have no idea what they were smoking back in the day to implement this like this, is that, where is this written? Here. So basically, 2 16-bit or 4 8-bit text cells are written at a time. Okay, so far so good. And so on. Only 32-bit addresses accesses are valid at byte addresses that are multiple of 4. Okay, somehow they don't write it. So they don't write it here so more precisely, but you need to decipher this here a little bit. And so this is address. So PCI byte address, 2 mega 32-bit words equals 8 megabytes. And so this is a PCI write address, and what this means, it's a little bit, so this is also why I overlooked this, right? This was like a little bit rare. So you cannot directly write linearly to the whole texture memory. You need to write it here to a very specially crafted address. So what this means is, normally when you write to an address, to a memory address, it ends up exactly at this address. However, not on the Voodoo. So first of all, so the first address needs to be 0, okay, because you can only write to 4-byte aligned address. But then further, so here is S and T, this is like U and V, basically this is X and Y, so X dimension and Y dimension of your texture. And normally you call this in texture space U and V, and I think in OpenGL Direct 3D maybe. And also in the S3 Verge, for example, they call this U and V. But in the Voodoo, because this is first generation and everyone calls this a little bit differently, so they call this S and T. S is X and T is Y in the texture space. And so this is the first strange thing, that you don't have the linear address. You need to shift and decode your X and Y address already, especially in the address that you write in the memory there on the PCI bus to the Voodoo. And then also additionally, the level of detail is the MIP mapping, and then the T-Rex is a texture unit, texture rendering engine, something. Yeah, probably. So this also means if you have dual texture engines, anyway, let's not make it too complicated. So what this means is you cannot linearly copy this, and also this means that because the Voodoo cannot know, this makes it super complicated, because on top of this means you need to already program the texture format registers, because the Voodoo needs to know the base address, because with this addressing, each texture you load with the same format. So the first, for example, if you load a texture, the first pixel X and Y, the first pixel here in the first corner of the screen, this would always be PCI address like 8 megabyte there in the address space of the Voodoo, because at first it has 4 megabyte memory mapped I/O, then it has 4 megabyte frame buffer, and then it has 4 megabyte or so of textures. And each of your textures on the highest level of detail would be memory address 8 megabyte there. So for the Voodoo to differentiate where you actually want this, you need to program additional registers, which is like, so you cannot, like, basically you cannot have your 3D engine running and bit banging there all your registers and in parallel load a texture, because normally you would be able to do this, right? You have your 3D engine, your game running, or drawing all the vertices, and you need to load a new texture. You just memory copy it to the texture address. But no, you can't do this. So because you need to touch some registers, with comments in the audience. So what this means, and this is even written there, here's somewhere written that some registers needs to be valid here somewhere. Like, yeah, so addresses are generated by adding texture base address and the offset that is a function of the level of detail SNT, TC-clamp, TC-LMPST or something, texture format load, level of detail odd lot, and so on, except for TC-LMPS or something, whatever that was. All of the values must be valid for the texture load. So this is so inconvenient. I have no idea. So as a software engineer, I have no idea how they ended up. I mean, you could argue like, yeah, it's doing fancy texture caching and whatsoever, but I find this so inconvenient. It's unbelievable. As a software guy, I would have like never. I mean, you would have had to pay me like to implement such a crazy construct. And this also means, so as a side effect, this means that you can't even read the texture back. So if you want to copy, I mean, you do not need to do this so often. It's documented here. Somewhere they write here that textures are stored. So somewhere they document, here, textures are write only. Actual order of writes doesn't matter. The texture data can be indirectly read by, so the texture data can only indirectly read by rendering a texture into the chunk frame buffer, though color differing alters the values. So you're like, okay, fine. But so this means you can't read the texture. I also don't understand why do they not allow this. I mean, they have here, so what this means is when you to write the texture, you need to program all the format specifying command registers. Then you need to write with this very special setup, so you can't like linearly memory copy the texture. You need to specifically, well, you could memory copy like all the strides, specifically crafted to these addresses. But yeah, okay. So you specifically need to bitbang this in this very specially formatted PCI address there. And you can't read it back. It's like, yeah, okay, you read it back. Yeah, don't really need to read it back, but would be nice maybe with, for example, if you have some defragmentation, like if you deallocate textures and like dynamically memory management is in a game like Doom or Descent or whatever, and you need a bigger space of texture memory, you can't even read it back, right? So you need to have your other texture like loaded from disk or have it in memory, unless you use some specially crafted isolated engine function to copy it back and forth. But yeah, so this is what I'm doing here. So normally we would just write this here to the increasing address of J, but because we can't do this, so texture address is by the way, is this even correct? Wait a second. We need to always. Oh, wait a second, I think this is even wrong what I'm doing here. This is only live on YouTube, you find a new bug. Because this always needs to be 8 megabyte. What have I done there? Let me check texture address. Where do I assign this here? IO base. Actually, this is slightly wrong. I just realized, probably. Oops. Okay. Anyway, need to correct this only live because, so this means we cannot correct this. So IO base, so yeah, this should be like that, I would think. You see the complexities. And also, by the way, this doesn't really, anyway, so IO base, so dedicated texture address range relative to the frame buffer pointer, and, oh my god. And yeah, then we need to have this here like text address, I think, because we need to have the real texture address because, yeah, so you see super complex. And what this also means, this is why I now call here Voodoo. I made a new function because I need to, as you've seen, I need to program this command registers for the texture format and the level of detail. All those bits need to be correct for the Voodoo to use this PCI address and multiply it internally with this level of detail offset, with the texture size and stuff, and with the texture base address, with a virtual address. Yeah, so yeah. That is what I wanted to show you here today. How many hours you can spend on all those details to get this right. And again, after, yeah, I just literally, you stare here so long, you debug through, and then live on YouTube you find another bug in your code. But yes, next is PS3 and other fun stuff. Let's see, it's also amazing that we have quite some people in the audience. Let's see what you commented. I hope the audio is fine, by the way. And also, if you have tips, what could be wrong? I'm literally running out of ideas what is wrong with the YouTube dashboard. Because in Russia it worked, in Berlin tests, I can't make this up, it's hilarious. And yeah, complexities of software, right? Software is so complex that even when I can write, well, kind of, I wrote something for the PS3. I have working, well, sort of some functions working for the Voodoo, nearly everything like kind of working for the S3 Verge, and more stuff to come. And yeah, can't even find out why my YouTube live dash, all the internet works, right? YouTube works, everything else works, just not the YouTube live dashboard, and it worked in Russia. And it worked in Russia with the same VPN to my German data center. It's hilarious. GPUs have registers, yes, so GPUs have, well, beside like modern GPUs and even, I sorted it away, even the first fully programmable rendition Verite has a real RISC processor, like MIPS, like RISC processor, so even that has registers, and even 256 of those if you want to watch that video. Rendition Verite, programming assembly and disassembly, disassembling their firmware, made a video 2 or 3, 4, 5 months ago. And so this rendition Verite and other like modern GPUs, like a decade or since Vertex shaders, even there you have registers for all the, what nowadays you also use with OpenCL and similar programming. And then so this GPU, the S3 Verge and the 3DFX Voodoo, they do not have like programmable registers like in the CPU sense, but they have plenty of registers, like it's still like computing something, right? Although you cannot, like the Verge and the Voodoo, you cannot flexible program like general purpose program, but you can program them to use this fixed function texturing. So the Voodoo and the Verge, they can only do basically kind of one thing, which is filling texture memory with a texture or shaded. And so the registers, it's even, they call it here registers, but they are not registers in the sense of a CPU where you can like multiply and add and stuff and move values around. Those registers here, like on this first, and even modern cards, so even the latest and greatest cards still have this kind of additional registers, memory mapped I/O registers, where you program what they should do, like those here. Register name, like status, to read the internal status, is it working, is it drawing, and the registers which the vertex points of your triangle, where to start drawing and where to draw on the screen and stuff like this. So yeah, a little bit different. Also, basically nearly all hardware, kind of, even a Sound Blaster has this kind of registers, or even kind of the very first IBM CGA, EGA, VGA cards, they have like registers where you program what the graphic card should output, video mode and similar stuff like that. Yeah, so not exactly called CPU, but very close. It's like chipset controller, so it's a GPU and execute instructions to the main job. So, and so even what I've shown here, the very first, like kind of, well, not really the first, but the first like 3D programmable, like a RISC CPU with MIPS like instructions, rendition Verite. I have a video there if you're into that. And I was in Russia last week. Now I'm first day back, just landed a couple of hours. Fun fact, just like 2 hours ago I landed here, Berlin. Fun fact, with my BMW i3 electric car sharing, got in a little bit in a fight with a Ferrari who thought he has special rights and take his rights, and I was regen braking to a red traffic light, and of course Ferrari driver, I need to overtake on the right and cut my way, regen braking to the red traffic light. Amazing stuff, not cool. So if you're watching this, if you're this stupid Ferrari driver, then hey, you don't have special rights, right? He was a little bit upset then, said I. Anyway, emergency flashed him a little bit, so he felt a little bit irritated in his special Ferrari goodness there. So yeah, sorry that I had to blink you, but that really wasn't cool there. Also, yeah, would be cool if you guys drive a little bit safe and not cut people when they regen brake to red traffic lights. Yeah, but that is stuff in greater Berlin area. So fun you have then 25 programmable pixel shaders of the NVIDIA G7. Yeah, so we continue soon with the PS3, but certainly this week something PS3 for all of those waiting. Also, yes, I know the comments. Why can I not do everyday PS3? Of course, we have other stuff to do, cannot do that every day, and also can't take the PS3, don't want to break, especially not the precious one here, the tool one. Of course, I have it here. Also, we will most likely redecorate here our office the next day, so maybe we have a slightly more decorative YouTube corner. For better, are you? Russia is amazing, comments of the audience. Yep, kinda sorta, why do you write this? Are you in Russia? And if so, where? And probably need to check with, yeah, maybe we take the IT news and for another day. So why do I not YouTube live stream each and every day? Because I can't travel so easily, don't want to break the two Linux capable PS3s I have. And so we have some other stuff coming. I actually exchanged some emails with Alan Cox, and which, fun fact, I even met in person. Probably it's on my old vintage blog, even a photo maybe of him 14 years ago, met Alan Cox. Fired him up an email because he wrote something on the Pulse Book. So what this is using Intel integrated graphic as with PowerVR. So we have plenty of stuff to come up, and you could leave me in the audience. So this is working more. You've seen I just found another bug, but otherwise this is working more now, but not yet fully. But I should be relatively close to get textured triangles out of the Voodoo. But to keep here people interested, the Sony Vaio P video is running very well. Lots of views, that is really cool, thanks for that. And certainly I would maybe use this nice machine here that I nearly only brought for YouTube. Let's see, does the battery still hold some charge? Maybe actually, yeah, I had it out. With the battery in, of course, the battery is, if you buy this kind of stuff from eBay, of course the battery then is not amazing anymore. Yeah, of course, Linux, but let's switch it off. So we will, a graphic for the Pulsebo is totally not amazing thing on Linux. And yeah, would be cool if we have some portable Road Warrior kind of hacking device here. So we need better graphics, and the graphics situation for this is totally not amazing. Theoretically, the problem is everything takes really so much time, because so this is PowerVR internally. This is not using like Intel integrated graphics, so not Intel's own graphics. The open source state for that is really not nice. It's like there is no open source 3D stuff. Theoretically, I had the dream of spending my time reverse engineering PowerVR, because I have this also in ARM board, so I have an embedded ARM board for that. Actually, wait a second. I think I have two. I have also a MIPS board. So we have the CI, the Creator Initiative or something, CI20 with MIPS, MIPS 32, I think. Dual core, I think gigahertz, dual core gigahertz, or even 1.2 gigahertz, not too shabby for all the stuff. So if you're interested in all this kind of hacking, don't forget to share, like, and subscribe. We have so much stuff coming. I have even two hardware stuff ordering, so a little bit oldish, but hardware stuff from eBay coming just for some review fun, and not vintage graphic card, more modern, but interesting anyway, I hope. And so PS3, this, so we will take a look. There is some accelerated 2D stuff. So right now the state is really not amazing. There was binary only stuff for this GMA Intel GMA 500 Pulsebo. There was some binary only stuff, but as usual, so it was a pain to use back in the day for even 3D, but binary only like NVIDIA. And as usual, especially with this not as popular stuff, not maintained. So it was hard to use back in the day, and it is of course totally bit-rotten today. If I reverse engineer this, maybe I have to reinstall a decade-old Linux crap just to reverse engineer this binary only stuff. And this is why it is amazing that you share, like, and subscribe, and welcome to all the new subscribers that we thankfully gain each and every day. And again, this is why I don't do PS3 every day. Not only would this be too boring for me, I guess it would also be too boring for you. But if you are interested in PS3, then try this ISO out. And yes, we will spin a new ISO image and makes this even greater. So much there you see how much time does it take, right? I spent a couple of hours already on planes and in the garden in Russia, in Moscow and stuff. Azar got drunk with wine and I was sitting there with my Voodoo registers and trying to figure that out, as fun as IT people are. And this is why it would be amazing. The goal of this channel, I can't repeat this often enough, I would want to spend more time, because again, I barely earn money with this, right? Who would want to finance this? So if we want to contribute to make all this open source stuff, not only for this vintage stuff, which is only an interesting educational hobby, but also GMA 500, not too outdated, PS3 and SGI Octane, and these projects are huge, right? So not only 3D on the PS3 and Octane take a month of development for sure, right? To really get something working. And this is NVIDIA PS3, we need to reverse engineer. There are no specs, we can copy and paste from the Xorg Novo or something driver. SGI Octane Impact is of course also not documented. I got some tips, but also huge work if we want to get this to work. And this also, there was a code leak, but should probably not look into this. Not even sure if this code leak for some OMAP or TI something, if this is even compatible enough, no idea. So no idea if this code leak there is of help, but maybe I should not even look into this. And so this reverse engineering Power VR will take forever. And I tried already to make this interesting, right? I work a couple of hours and present you the interesting findings. I think if I would sit here 8 hours and PC emulator, I think this would be too boring. Certainly not the best time of you spend watch me 8 hours debugging PC emulator. But yeah, so this is the status. Lots of stuff coming up. All of this, as usual, leave me in the comments below what you find, or right now or later in archive video on demand. Leave me in the comments below what you find the most interesting, what you want to see. I certainly usually do also what I like to do, but I can of course prioritize a little bit what is more interesting. Certainly, yes, I understood PS3, yes, here it is, certainly for good measure. It's not forgotten. Also need to work on the camera angles. Most likely will rotate your tables around to have maybe a slightly more presentable YouTube corner. And let's see, more comments. Must be a hard job to program a driver for 1 GPU. Yeah, so this is also why I start. I'm a driver developer. 500 reverse engineered scanner drivers for our amazing, certainly I can show this exact scan. But also I fixed a couple of things. I always did a little bit tweaking for the SGI Impact already a decade ago. Then there was always like the ATI and NVIDIA stuff. There was always for the Cube. And yes, we also have, by the way, it is T2 release season coming up. We have done so many updates on T2. We will spin new ISO images for all the architecture. So we will have test afternoon for the Spark, for the PowerPC G4, G5, and Hewlett-Packard PA-RISC, Octane. Winter is coming, right? All the fun stuff, heating the office with SGI Octane and stuff, and trying to improve stuff. And yeah, these are basically the overview and why I present this. Even if you have the documentation here leaked in terms of the Voodoo, even then you need to, even then, for example, I still didn't get texturing to work, right? So it could still be I interpret some, even if you have the specification, some things are unclear, right? So you first need to realize you naively copy linearly the texture that doesn't work, and until you figure out they have this brain dead kind of special address decode nonsense. And additionally, of course, by the way, maybe I changed this slightly different here, that not this is a little bit unreadable. Even if you have the specification, some things are unclear that you need to figure out. Let's do this here. Let's use the IO base, so texture address. So this is here for a test, the texture address. This is just a virtual offset for testing. This makes the second, this is level of detail 1, I think starting from 0. So this address is exactly, this by the way should be equal to, I think maybe 512 multiplied by 4 byte divided by 8, I think. Need to check this later. And then maybe we make it so that we don't use the texture address here, but because this is wrong, we need this should be an IO base, that is the distance from the frame buffer pointer to the 4 megabyte. I think this is probably the most readable. So yeah, why do I present this? I present this because not only I want to show everyone, you see, as the Debian people call me unsuccessful one-man distribution idiot. Even, you see, even a uneducated failing one-man distribution idiot can write graphic drivers. Takes a little bit of time and trial and error, but I can do it, so you can do it too. And you don't need a computer science degree, which, okay, granted, I studied computer science, but in my opinion, you don't need. Every teenager could read the spec and implement this. I want to take a little bit the magic and difficulty level out of this and basically show, hey, everyone can do this, and inspire everyone to hack on the Linux kernel, contribute. If something isn't working, don't wait for upstream people. Take a look yourself. You can make potentially, well, although I made a video how to earn money with open source, not so easy, but theoretically you could end up working at NVIDIA, AMD, Intel, and fun stuff like that. And yeah, that's it basically for today. But as usual, when we basically want to stop live streaming, then the most people tune in. Theoretically, we could continue with some amazing IT news, which the last live stream also broke. Also today, 0 drop frames, also VPN through the data center. And driver programmer, so must be kind of easy for you to develop driver for. No, so for the, I mean, this is really funny. I spent a whole video, multiple videos showing you how difficult it is, and then you say it's easy. No, it is not easy, because, so first of all, as I showed you here, the hardware is full of quirks, and even if you have a specification, even then it's super difficult, right? And the RSX is not documented, so although we can copy and trial and error from Novo, one thing that the PS3 is also a little bit of a bitch, quoting Louis Rossmann there, ain't a half bitch, it's a full bitch in the sense that if the RSX gets stuck and doesn't like something, then it's right now crashing. In the sense, it's, well, it is nice when it's a full bitch and it's crashing, then it's nice, and it's throwing us through the hypervisor in interrupt and indicating us an GPU exception. But I have not yet found out how to recover from this. So first of all, it is super difficult. So why do I start with this outdated vintage Voodoo and 3DFX and S3 Verge? Because this is simple, right? I have specifications leaked there on the internet, and this is the first generation that is kind of easy. Although I find it a little bit silly that on the Mesa source they deleted this, right? So I'm not agreeing that they don't, like, yeah, we don't want to maintain this old-fashioned API. So we deleted this, which I don't really find amazing. And again, for this Lynx 3D here in this Oko 01, which I also quite like, I'm really fan of esoteric devices in my collection here of outstanding stuff. And so never, so the vendors, 3D Silicon Motion, never wrote, they only wrote a Windows 95 driver. They never wrote a real protected mode driver for Windows XP or Windows NT or Windows 2000 or something. And so the Oko, the original device vendor, never shipped this. When they sold this for good money, $2,000, right? Original price there, MSVP or something, recommended sales price. They never shipped this with a working 3D driver for Windows XP, right? They shipped this with Windows XP Tablet Edition without 3D support. Like seriously, what are those vendors thinking? Can't make this up. And so there never was a 3D driver for this, for Linux or Windows, real protected mode Windows. So just to show a finger to, well, it's old, outdated stuff, right? But just for the sake of it, I know nobody of you is probably interested in Silicon Motion, Lynx 3D, but anyway, I will just do it because I want, and want to show that it's possible. And then the only driver since, yeah, ever, protected mode driver. I hope it's possible. Again, the documentation that I found leaked, well, it was on the FTP server of the vendor, although in the meantime they took it down. I have a backup copy of that, and that is even more difficult because this is so funny. The registers like this are documented, but like only very briefly. So 2D is like this and that, and you do it this and this. So 2D is so 200 pages of 2D, which is like basically trivial, and then 3D, the specification 200 pages 2D, and then like only 20 pages 3D, which is of course hilarious. It's the most complex and complicated, and at least they have documented the registers a little bit like briefly, so I think I could get it to work, but because it's like so sparsely documented, I think it's probably still quite challenging. But nonetheless, just for the sake of, I just want to do it just because, why not? And maybe I end up, so again, all of this, the Voodoo and Matrox and even SES and VR, once upon a time there have been Mesa drivers for this early generations of 3D cards. I find it really sad that it was deleted in Mesa. I'm not agreeing with this. They basically say, yeah, this is outdated and low, doesn't support the features. But again, you see this code, unsuccessful one-man Linux distribution idiot can write this here in a couple of afternoons. So this is not so much code. In my opinion, I find this really sad that the open source community has like abandoned this. Yes, this is first generation and slow. And anyway, for people who would just have it running for vintage and retro sake, I still find it interesting. Yeah, I don't have experience, so yeah, this is cool that you, Paul, thanks for joining. No, I don't have experience. I have, I have a TI, I have the Beagle board or what it's called, and this is a TI ARM with Power VR. I think so. I have probably the official image on it, but if I could probably download it. I think the official image probably has some binary only drivers there, and I have the imagination tag. I also have the official image on the CI20, this creation inventor something MIPS. This is dual core MIPS, and so I could maybe reverse engineer this from this. And yes, I have the feeling, so there have been reverse engineering efforts that didn't get much traction, I think. Yes, this is why, again, people say this must be easy. No, even this is not the most easy. Even there I spent hours debugging through PC emulator, and this is why I want to train not only myself writing this from scratch, getting to understand. Of course, again, I knew this, like programming OpenGL and stuff, you have some understanding, but again, it's totally different to use an OpenGL API than bit banging here yourself low level the registers. Yes, I have totally know Power VR will be just totally difficult. Fun fact, I mentioned this again, I would stop the live stream. I probably wanted to go home, but it's always nice to have people in the audience. Just makes the streams a little bit long. To be a Mesa dev, they won't delete drivers, they are maintained, and probably wouldn't people ported all drivers to the current API KMS. Yeah, anyway, so the problem is with this, I understand unmaintained, but in my opinion, it's also more difficult to revive them if they're unmaintained. Also, I would like more a microkernel stack where rewriting all my, if you're interested in microkernel concepts, my microkernel philosophy discussions. I find this rather complex in Linux to develop because you have some parts of the driver in the kernel and then you need to create a matching ABI, and so if you have some parts in the kernel, frame buffer or mode setting and direct rendering manager, and then libdrm for command validation submission, and then also Mesa and the X server. So yes, you have like 4 parts. I would prefer like I would actually find this so much more easier to have in a microkernel, multi-server microkernel, one component that is like the graphic driver running in one task and not the spread over 4, but yeah, performance and whatnot. But yeah, in my opinion anyway. So yeah, I have, coming back to Paul, yes, I have completely no illusion. It will be totally difficult. Fun fact, I nearly a decade ago, when we did more embedded Linux stuff before we dived a little bit here in commercial software, end user software that made having here some sustainable income a little bit more easier from all the videos previously of how to make money with open source. We nearly scored creating an open source Power VR driver. I said this already before. I even mentioned this in another video, let's see, Google, and then how many, hey, 0 drop frames, VPN to the data center. Tegra NVIDIA blog. I even published an email on my blog where I wrote NVIDIA, resist NVIDIA. So after a decade I published his email. So this is already, don't make this stuff up. This is copied from the original email. Published this here already quite some time ago in whenever, apparently maybe 2018, if this is correct, no idea. Anyway, so basically we even wrote NVIDIA, hey, we have a project, this was like, think of like satellite box or car navigation system, something of that sort, when we were doing this as T2 and all this other embedded stuff, all the stuff we've done. So basically people wanted embedded Linux for, I think it was NVIDIA Tegra or something. And so basically we wrote them, we would have reverse engineered this, but of course it's always nicer with cooperation with the developer. So we wrote them for a currently ongoing project. I wrote this to NVIDIA in 2008, and for a currently ongoing project we need solid 3D support in our portfolio. We would kindly ask for the possibility to sign an NDA. So I even thought, and there you see what a double standard this is and what an insane environment to work with, right? You want to make embedded Linux totally amazing, most outstanding car or in-flight entertainment system, anything. You approach vendors. At that time, right, in 2008 I've done Linux 10 years, right, studied computer science, and you approach NVIDIA, they have a failing product that nobody wanted with embedded Linux. Who wants embedded Windows, right? And I even told them, look, I signed an NDA, and to receive register level spec support, NVIDIA latest integrated embedded SoC in our board support, like the abbreviation BSP board support package or something. And NVIDIA wrote, so the only thing there you see how amazing is NVIDIA, right? You as a company, Exacode, a decade ago. And this is why a decade later, I don't really have good contact with NVIDIA anyway. I don't really want to burn my contacts. Of course, I have contacts all over the place, from Apple to whatever. Usually, although I'm a little bit critical to Apple, but whatever, it just sucks or whatever. Really, if you make a YouTube studio live stream here like we do, always a little bit on the edge of burning contacts and pissing them off too much, just like Linus Tech Tips and stuff. So as a company, GmbH, like really registered, like not some shabby garage business, 10 years of Linux experience and study computer science. You approach NVIDIA, say, hey, we want to write open source, or actually open source. We want to write ourselves, right? We don't want money, we don't want anything. We would even sign an NDA. And NVIDIA, the only thing, so basically, if NVIDIA complains that Linus Torvalds shows them a finger, right? Like, excuse me, NVIDIA, you really don't deserve better, when the only response you write to a Linux company, embedded Linux company, we want to do car entertainment, in-flight navigation, their entertainment stuff, satellite receiver box stuff, and you reply to a company, how is your Windows CE experience? Like seriously, NVIDIA, F-check yourself, really, seriously, you deserve like zero support from us. And we are not supporting Linux on Tegra, like, yeah, that was 2018. So yeah, this is what you get from binary only stuff. Can't shout out this often enough. So yeah, NVIDIA yourself. Let's see what we have here. Ask biggest, you have BeagleBone Black, which, so Ismar has a BeagleBone. So I have an early revision Beagle board from a decade ago. Let's see, to be made this, so I had this, maybe try program one game, run Linux on a PS3. Yeah, so maybe, by the way, ideally, why do I do this? So first of all, I want to preserve the history, like on a C64, on an Amiga 500 and stuff, you can program demos and stuff. I want that basically not only educational for myself and you have here this out in the open from Verge and Voodoo and so on. We will continue also with others. I also want to be able to people to program this, and you see this is not so much code, right? This is just a couple of 100 lines of code, not the most readable yet. I will polish this another day, and yeah, I will most likely, my demo was not the most amazing yet. Can find this also on, okay, let's go this here too, or actually we will find this with Google. I will most likely create a more amazing demo, Verge, and so maybe, of course, this is the demo here right now. This here, some spinning colorful cubes and the texture, not the most amazing. I will most likely, at least, cursors here, I will most likely, eventually later this year, write, yeah, also first failing texture attempts. When all those registers are not right, then your texture looks like this, obviously, naturally. And I will most likely write a more amazing demo, maybe some X-Wing versus TIE Fighter stuff flying there around, maybe even playable, and maybe some little bit Starship shooting stuff. Of course, eventually, gradually, like one after. Maybe like the 8-bit guy next year, we will make a whole space shooter, I don't know, maybe. By the way, how do you can motivate me? Have this video running in a loop that we generate more than $3 AdSense revenue, send it to friends and family, your significant other, colleagues and friends and family, and post it somewhere, and that we get more views from audience. The more we earn this, and yeah, unfortunately it's a money thing a little bit. I can't jeopardize all my income earning nothing with all this educational stuff. So the more you share, like, and subscribe, and the more than $3 a day we earn with AdSense, the more I can do this amazing stuff. And so yeah, eventually we will get there. At least some flight stuff, not eventually it will be playable another day on the Verge and Voodoo and others, and PS3 then eventually. Which I haven't used for years. If I recall correctly, back in the day, TI couldn't provide Hasselblad GPU driver Linux for a long time. I think the Beagle, so I have an earlier revision, I think mine has binary only stuff. I thought it has some libraries and is doing something, but honestly we never used this already. It was for ARM development, but I thought it has. But anyway, I think at least on the Imagination Tech Creator Initiative 20 or CI 20 or what this is, I think at least this, I think both though come with this, but yeah, it's not fun to reverse engineer this binary only stuff, obviously. You ask, so my biggest interest is cell power in some way. Yeah, we will continue this. I don't know nothing about programming, just read everything about IBM Cell. Okay, that is also cool. Couldn't even find a frame buffer driver for it, but maybe looking in the wrong places. So it has a frame buffer. So usually for the OMAP you find a frame buffer. Also for this Intel there is a frame buffer, but it's of course super slow, right? This is already Intel Atom, the Z500. Although this is this is a Japanese special edition. If you want to see video there, Japanese special edition here with nice Japanese characters, which looks actually quite. This is also why I scored it for not too well. It was expensive enough, but not. Why does this? Oh, it's a battery, right? Looks actually, my opinion, probably. Yeah, Japanese looks pretty cool. Probably nobody else and not too many people bidded on this in Germany because Japanese, but actually it certainly looks geeky. And yeah, so this and the others, there is a frame buffer, but frame buffer is of course not the most fun. You of course want graphic acceleration. This is why I mailed Alan Cox that we at least have. I will try to maintain it. So what we will do, the next initiative, not only I'm one of the few people who is doing SGI Octane stuff. We will keep advancing, maintaining this PS3. All the fun stuff, and we will also, there were others, but even this, the last people who did there was someone from Finland or Denmark or something, I need to check, who has done at least some 2D acceleration for the GMA 500. So first we need to try to get this working, and then this will already, of course, will take hours or a day to just get this bitrate and code, do something maybe, hopefully. And yeah, this might be more interesting for more people because at least this is Atom, at least there are a little bit more people who have this. And kind strange, remember there was who's what Angstrom distro but failed provide hardware acceleration. There's no Android driver with acceleration. Yeah, this is also why I on Phoronix everywhere I always point out this sucks with NVIDIA. I also don't understand all those Linux fans and fanboys and enthusiasts, why do they use NVIDIA hardware? Please stop. I understand a little bit performance here and there. If you are Linux focused, please, I'm begging you, buy open source supported stuff, either Intel or, of course, if you understand Intel is a little bit low performance, if you need high performance, go AMD. Yes, previously it was a little bit, not a little bit, maybe less performant or a little bit more energy hungry. Yes, it sucks for Friday for Future and the climate crisis, but the climate crisis is so bad, a little bit AMD GPU doesn't hurt that much. Yes, it could be better, but vote with your wallet. Don't feed NVIDIA, really, seriously. NVIDIA is not a half bitch. NVIDIA is, speaking in understandable Louis Rossmann terms here for the native English speaking, NVIDIA is not a half bitch, they are the full bitch, like such a bitch. Please don't buy NVIDIA. Support companies that invest heavily in open source drivers like AMD, like ATI previously. This is why I personally, even I myself, I'm not a double standard. Yes, I have a little bit NVIDIA where I couldn't avoid this, but when I brought the Apple G5, which by the way, fun fact, we will also continue with the Apple G5. When I purchased the Apple G5, I purchased the lowest, cheapest NVIDIA because there was only NVIDIA. I needed Apple G5, PowerPC 64. The only thing I could do is order it with the cheapest NVIDIA to give them as little money as possible. And I was very well aware that for many years, I will not be able to use any hardware acceleration. Nowadays it works a little bit thanks to all the Novo reverse engineering, but initially when I got and how much does it suck? It sucks so much that when I had the G5 new and with mailed there with Benjamin Herrenschmidt from IBM and PowerPC Linux fame, initially not only was there no fan control, so the fans spun at 100% because proprietary Apple fan control bullshit, but thanks to the amazing Benjamin Herrenschmidt, this worked relatively fast then, the fans. But initially I had not even a frame buffer. So initially I used the G5 with this crappy F-checking NVIDIA with an unaccelerated open firmware frame buffer, like the boot graphics, like slower than frame buffer because even less accelerated, not even scrolling accelerated, like totally slow piece of garbage. And that is what you get with binary only. Yes, there was a binary only NVIDIA driver, but only for x86, and obviously that was no good, never. You could never have a PowerPC driver, as far as I remember, for NVIDIA on PowerPC. So thank you, NVIDIA. You deserve no send negative things. Here I'm not the only NVIDIA I got by accident. I never purchased it willingly out of free will, like on the PS3. Yeah, and so yeah, this is also, yeah, this is why this sucks then, right? If you have slow hardware, not only the PowerPC in the PS3 but also ARM there on Angstrom Linux and stuff. Yes, it sucks when you have slow ARM hardware and low power and so on, high efficiency, something ARM, and you really don't want you use your CPU, because then you can't even play video if you use all your CPU cycles to bit bang your memory copy your video to the frame buffer. And this is why, again, this is why I constantly call out NVIDIA, why I do this educational videos, and what trade secrets are there in NVIDIA. Just finally release this kind of documentations, and it is so bad on NVIDIA, you know. All of you probably know the latest NVIDIA hardware you can't even use with Novo. You could, but they even in the meantime they cryptographically sign the firmware. So the NVIDIA people, as the Novo or Nuevo people, don't even have the firmware. They can't even load the firmware for even. And how ridiculous is this? The firmware is for fan control and clock management, and you can't even run. So even if you run Novo and Nuevo with many of the last 5 or 10 years of graphic cards, you don't even have clock management, so it's running on boot clock, no dynamic scaling for power efficiency or for highest performance. It sucks from top to bottom just because they call this intellectual property and trade secrets. I call this specification for the hardware that any developer should have for what you own. And yeah, I'm sorry to hear this. Yeah, of course, if you have this already and can't give it back, I understand. I also have this I have some NVIDIA where I could avoid this for the Mac stuff, but otherwise, yeah, I'm sorry to hear this. What else do we have? My company got me NVIDIA Jetson Nano though, fully authorized proprietary blob, of course. Yeah, so this is again not, and they will stop updating this, right? And also you have some features like virtualization they don't support on consumer hardware just because they don't want, because they are NVIDIA, and yeah, not cool, nothing. And do you have much registers have one? Do you know how much registers have one Pentium 4 of 2005? So Pentium 4 probably was x86. So x86 has very few like registers. Very few. You have there AX, BX, CX, DX. Was there X anyway? So and then on x86 it's a little bit strange. So you have some special purpose registers like segment, code segment, data segment, extra segment, FSGs. And so on, so it's a little bit hard to tell, like maybe it's like 16-ish, but you can't really mix them. So many of the, all of the registers, some registers are for general instructions, like general math stuff, like add, subtraction, and others are like, you can only use as pointers for segments and offsets. So yeah, a little bit not so easy. But so the Pentium 4 probably is 32-bit, so it has very few general purpose. I don't know, was it 4 or 6 general, maybe 6 general purpose registers, something of that sort, plus or minus. But with AMD 64, of course, again, it was not Intel who invented Intel x86 64. This was AMD, right? Intel had this failing Intanium that they recently cancelled forever. And AMD invented this, and with AMD 64, they expanded this. So if you run 64-bit code, you have, I think, like it was like 16. So vastly expanded 16 general purpose registers up from 4 or 6 or something of that sort. And yeah, something of that sort. It's of course amazing. We have so many comments. What do you think? Stuff Raptor Computing is putting out. Interesting that we get so many comments. It's of course amazing. Makes this live stream a little bit long. So the initial stuff of Raptor was a little bit expensive. The new stuff is a little bit more affordable, of course. Yeah, I understand it's not like mass produced. This is why I said, by the way, one other video I shouted out, if we get 1,000 likes or something, which is of course hilarious, which we will until we reach 100,000 subscribers probably not get. But one of the previous live streams or something, I said if I get 1,000 likes, just for the promotion, fun of it, I would order one. I personally find it a little bit expensive. This is why ideally I could get one. Well, I have the money, right? But I also have other stuff to buy and finance, so I'd probably better hire another developer than spending my money for some PowerPC stuff. I have a G4 Cube, I have a G5 dual core with the last generation dual core, and maybe I try to upgrade it. I have a 2 GHz, so I have a P3, so I don't really need this, and this is why it's for the performance you get. Probably because it's so low volume, a little bit overpriced, but I fully understand this is a small company just like mine, and if I would produce such a low with my team here, if we would produce such hardware, of course it's super expensive, all the software development and hardware development, developing the PCB, testing it, of course the first PCBs will fail, something will be shorted, something will be misrouted, misconnected, there are the pins, some stuff will not work and so on. So yes, of course hardware development is super expensive. This is why this low production run is so expensive. But because I personally have already an SG Octane, of course cheap from eBay and stuff and so on, I have a P3, so my time P3 fans demand I do P3, so I better my time is spent on P3 and not buying more stuff that I can't properly use. And yeah, this is why I need high performance. For high performance I will go AMD Ryzen as soon as next month, that you share, like and subscribe for the 16 core 32 thread AMD Ryzen update for all the more mainstream stuff we do here. Probably my money best spent for the best performance, bang for the buck. And yeah, so many comments now, which is of course super amazing. Let's see what else do we get. Kind of strange. Remember they were so interesting about angstrom. Okay, we had this, and which can say that Cell does 230 gigaflops with all 9 cores on the PS4. Jaguar does 102 something. Yeah, okay, if you especially program this, of course. Okay, the Pentium 4 we had. What do you think of this stuff? Okay, Raptor, Compigol, okay, and NVIDIA Jetson. Yeah, I was thinking to get an NVIDIA Jetson just for the ARM64, but on the other hand, maybe I rather, okay, I was thinking about a Nintendo Switch. I probably should have gotten one when this hacking was new, just for the YouTube views. But yeah, not really up to supporting NVIDIA buying this full. I would get one for ARM64 testing, but then I don't want to give NVIDIA that money. Satisfy board, okay, we had this. And AMD are only power hungry because they have their voltage levels higher to maximize yield for the target market compared to NVIDIA. Yeah, and again, what for me it is more value that I can really use it to the fullest extent on open source and so on, and yeah, on the AMD. I will, by the way, so I will probably soon get the AMD, now that we got here, I said it again, you have seen this if you want to view my history here of all the stuff I showed you, the G5, again, we will get the G5 up and running here for the next T2 testing of, again, this is dual 2 GHz, right? It's still relatively okay-ish for all the T2 testing for the new ISOs and stuff. And what was my point? My point was something of AMD Ryzen, and this is why to review this stuff also in the Linux content, I will get this new x86 mainstream stuff, because historically with also our Mac software we have been a little bit on Macs, as you have seen, but there are peak bugs, they are not amazing, falling apart, external throttling, will not buy them, especially the new ones with all the fake security and the failing keyboards and all the other bullshit and T2 crap and whatnot. And this is why we stock now with PCs. We migrate back to desktop Linux and virtualize Windows and Mac OS, and everything is more amazing, certainly. So not only Ryzen upgrade for the next SKU as soon as it launches, but also we will get a Radeon 5700. Actually, fun fact, I wanted to order the reference card, but then I realized from all the mainstream YouTubers that the reference card blower cooler sucked apparently with the noise levels and cooling. So I will now get, as soon as they ship in Germany, like cooler, power color, or the other whatever. Ah yeah, right. The Sapphire or something. I will probably get the Sapphire 5700 AMD, because this is, as you see, we can mix and match much more flexible. PC building stuff is so much more amazing than this limited Apple stuff where you are stuck with what you get and you can't, especially with the trash can and cheese grater crap. So with the PC, it's so much more amazing. Just upgrade the CPU, latest Ryzen, slap a AMD Radeon card in there, so we will get that. I hope this is then quite amazing. Certainly, hopefully the 5700 latest RDNA is probably high-ish performance and not too energy hungry, I hope. And more comments, so Pentium RX. So also, yeah, so this is all for September topic or stuff of that sort. 128, yes, so cell, but many registers only help you so much. All the registers of this single instruction multiple data you can't compare so directly, because you have a much higher thread count running on those. So there's many registers, just like on the very first rendition. Verite also had like this very old vintage even had 256 registers, and you could only use half on this GPU from 1996. Many were like hard-coded to constants for multiplying with RGBA masks and stuff, and other 0 and 1 and such kind of constants. And like it had like 120-ish general purpose registers. Doesn't help you so much if you have, like, this first was 25 megahertz or 30 or something. Risked, of course, not the most highest performance. So this registers most likely, like vertex shader registers, are shared usually with all the threads, but you don't need so many registers anyway. So these are split by all the threads that you're running, massive parallel, all your 16 threads, so you can't. But anyway, you don't need them anyway. You have incoming data, you multiply, add and fused, multiply, add, summarize, saturate and whatnot, all this fun stuff. So you don't need so many per thread anyway. But so it's not that, it's like saying an AMD Ryzen has 16 multiplied by 16 cores would also be quite 128 registers or something, so it's not really that comparable, but yeah. And also, yeah, each 128-bit, of course, the latest x86 single instruction multiplayer data also has AVX, even has 512-bit or split in whatever you split this, and before that AVX2 and stuff also had like 256, 128, and yeah. The Ryzen machine, ironically, to do 32-bit Linux. What do you mean with 32? This is welcome, Andres Baumann. Yeah, not getting, which of course, yeah, this is like 32-bit, like this amazing machine, you're right. And when people always on foronics like a crappy 32-bit, it's not so crappy, right? People still have a lot of vintage data, and again, this is only a decade old, and it's slowish, but it's, in my opinion, not so bad. It's slow, but hey, I think it's a really nice machine for like, no wonder that's in Hollywood movies they use this, and Girl with a Dragon Tattoo and somewhere else I recently saw it also. It's of course nice to run around with this. I mean, yeah, it could be faster now with GPD2, but something, whatever. And also, yeah, people, in my opinion, what I want to do with this YouTube channel, some people need to maintain, well, need, but if you want upstream support for this kind of stuff, you have seen in a decade very few people. Well, Alan Cox, when he was employed at Intel, he has done something on the GMI 500, of course. Cool stuff that they at least have done something for 2D, better than nothing. But this is what I tried to, or still try to build this YouTube audience to finance all this broad spectrum of stuff that is not as amazing in open source, that could be done and could be better. So the more people share, like, and subscribe, the more fun stuff we can do. Too much and too fast. Sorry, I only try to not try to get the stream too long. I wanted to already stop, go home and eat dinner and stuff. Wife is probably getting crazy that I live streamed long again. This is why I sped up a little bit with this commentary and summary. Before, I hope in the beginning it was slower, but usually when it's getting too long and I want to get home and get out of here, then anyway, I hope the people enjoy it anyway. And PS3 is 13 years, GPU is better than PS3, PS4, enjoy. Yeah, thanks for watching, this was amazing. I hope the end was not too fast. And see you soon, amazing stuff, of course, amazing that we have 16 people. So this is all stuff is coming. So this, PS Sony here, Sony there, x86 and all the fun stuff in between, left and right. Thanks for watching, thanks for sharing, thanks for liking, hope to see you soon. As usual, sorry that the stream became too long for those people watching it later. The beginning was, of course, here's a programming summary, and then it, as usual, much appreciated comments, but then the live stream usually becomes a little bit long. Still, if you have tips, what this bloody, I really don't understand why the cool that you are here for Voodoo stuff. That is good to hear that I'm not only doing this for myself. If you have tips, why this bloody YouTube, this is so bizarre. I already tunneled to the, so any tips taken, why this bloody YouTube live dashboard, it was working before. I was so surprised. You see, it's not like my browser, it was just magically working in Russia. Even when I, for the throttled YouTube, I was tunneling it in Russia through the same data center that I'm VPNing right now. I have totally like zero idea why it doesn't work when I'm on the same VPN tunnel to the same data center. It still doesn't work. It's hilarious. And so yeah, no, maybe because I talk too fast. Phone should be pronounced moronics. Yeah, welcome, Dave. Also cool that people enjoy Voodoo. And again, so the fun fact, I understand. So the problem with this is the last shout out, and then we really stop it for today. Also, I think it's not really focused because I have it on manual focus, because before it wasn't anyway. Does it focus? Maybe, maybe not. But anyway, we are not done anyway. So I understand it is slightly boring that the programming also, it's upside down. The programming also can open it so that you see it in more. So the programming for this Lynx 3D Silicon Motion will be similar to the Voodoo and the Verge. And there you see what double standard this is, not to publish the register specification as well. Ironically, for this we have quite okay-ish register specifications. The more sad it is that we never had a 3D driver for this. And again, there were sync pads and other fun stuff. So the problem with the YouTube content, and to explain is why do I ask, maybe I even stop the stupid YouTube stuff, sharing, asking for sharing, like, and subscribing. Naturally, if it's interesting, you probably naturally share, like, and subscribe already. Why do I repeat this? Only because we really need more people in the audience. And yeah, it's totally amazing. Thank you for everyone subscribing. Couple of new subscribers every day. That is amazing. Because the problem is, if we want to make this open source stuff greater, like PS3, and yeah, I understand this is not for everyone, but maybe the GMA 500 is more for everyone. But it's just bugging me, right? We have the specifications that, yeah, it's a little bit lacking, it's a little bit brief, but I think we could probably get 3D. Well, this like first, second, third generation 3D. It is not amazing, but it's better than nothing, right? The problem with the YouTube content, first of all, I miscalculated that even for me, with quite some reverse engineering experience, it takes really long time. Especially this is underdocumented, right? Even the Voodoo, it is documented. Even then, you make one mistake, one bit there, you debug forever, 1 hour, the second hour, then a whole week, and kind of, sort of. And this will be the same, right? And this is a problem with, I miscalculated, like I thought, like a little bit like Linus Tech Tips. The problem is it takes so much time filming it. This is why in the latest weeks it's mostly live streams, because it's more time efficient. If I record everything and edit it, then it takes like 3 times the time. And then I can chat with you in the audience. And the problem again is a little bit the content of this. The programming will be similar, and this is what I think makes it a little bit boring, not only for you but also for me, for the programming. It is also in retrospect, it's a little bit sad that there was specification. It would have been possible, and the code is similar to existing code in Mesa, yet it was never implemented. This is really sad, and this is why I try to motivate people like you to also help, send patches, install this on the PS3, and yeah, let's see comments. The channel NSC Mods is German too, but I can understand everything he says, but he speaks slow in English. What? But I can understand everything. Yeah, okay. I understand. Usually I already try. I hope my regular videos are better. I hope also the beginning of this video was better. It's only that the length of the video, trying to get out of here and finishing with the comments, made me speed up here this a little bit. Thanks for joining. We need more GPL 2 license drivers without any PC problem. Yeah, this is also the problem with the latest Intel or even AMD and Nvidia, that it needs proprietary blobs. You have seen even in Russia, some live streams failed because the Wi-Fi firmware was. If it has this even in, let me quickly, although it is slightly, yeah, now I will bring here some IP address, of course. Let's less here var ADM, no, not ADM. Can't make this up, but I showed this already in Russia, relatively live-ish. What? Even the Wi-Fi firmware crashes, right? Firmware load. Here was some, but I showed this already live there. There would be a couple of boots in the meantime. Firmware bug, probably. Firmware bug. Can't make this up. Wherever you have seen this, maybe how many boots could this have been? Here we are, something. Whatever, you have seen this, but this is really so sad that even, and you can't really do much then when this proprietary blob, maybe here, yeah, here's a crash, I think. Microcode, it's not from a microcode. Yeah, so And I have similar, I said this already, I have a similar issue on the Surface with Atheros, what is it? No, it's Atheros. Yeah, so microcode software error detected, restarting, and yeah, I can't even live stream then over Wi-Fi, over some comrades, neighbors, Wi-Fi, because your Intel firmware blob is crashing. Yeah, not cool. And this we should also not, in general, in my opinion, not only for security, but yeah, can't really debug this, can't fix this, and it's not amazing. A friend of mine wanted to do this macOS virtualization on Linux after seeing Linux tech tips. Luckily, I think I... What do you mean? Luckily, I think I dissuaded him. Yeah, we will. I actually do this. I've done this long before because I'm one of the initially. Alexander Graf here of Germany is the original developer of this. But I took over maintaining this. This is why you find my name. So, fun fact, we have done this here, Alexander Graf. I continued maintaining this. I even earned some money for some Silicon Valley company where they use this also commercially, this Mac virtualization in EmuKVM. And then I planned to make YouTube videos. We will soon do this. Also, yeah, now Linus Tech Tips beat us to that. But yeah, this is also fun stuff that we come here because I never used GPU pass-through with macOS. I only used it. Shouldn't say it. I have it running here. Not that Apple comes here and harasses us, but we have it running legally on a Mac Mini and Mac Pro only, because certainly only legally running macOS virtualized here for only development purposes only anyway. In Russia now? No, I was last week. I answered this. Now I'm in the office, as you see. Office. Already said. So okay, cool. So yeah. Why do you ask, by the way, Victor? Are you in? I asked you already. Are you in Russia? Anyway, maybe. That's it for today. I hope you learned something. So much fun stuff to come. And the more you share, like, and subscribe, the more motivate and finance this here to hopefully do so much more in the future. Well, I already do a lot, probably. And honestly, this YouTube stuff is a lost business because all the excessive time spent, I don't earn this high salary you earn with proprietary commercial work, obviously. So with all the equipment and time spent, massive lost business that we invest here into the future of this channel. And yeah, this would be cool if eventually we could turn this, like other great YouTubers, to a more financial viable endeavor and developing all this stuff. That will be up next. So yeah, have a good night. Thanks for watching. Hope to see you soon. And anyway, stuff like that.